So I'm sure you probably heard of examples of distributed generation, or also called as distributed resources. These are examples like such as wind turbines, solar panels, and the government's been really pushing towards connecting these distributed generators onto local utilities to supply power. However, there's one major technical barrier about connecting these distributed generators. Now, I'll illustrate what that problem is. It's specifically called islanding. Now, if you look at the slide number 1, this is what the normal situation you want. You want the utility to supply power to your customers, which is your homes, your factories, and you also want the distributed generator to supply power as well. Now, what happens once in a while is there's disturbances in the lines. And what will happen is the utility will open its breaker to try and fix these sort of faults. So what happens because of the generator is you create what is called an island. Now the island is such that the distributed generator is supplying power to customers independent of the utility. Now this is a problem because the utility, not knowing this, will send a worker, and the worker expects this to be de-energized. But in fact, it is energized by the distributed generator. And also the power is not regulated by utility because it's disconnected, so you damage equipment. So these are some of the major problems that is with islanding. And I'm sorry, Vonia.
I like that.
I'm sorry. I'm just really tired of it. So Vonia's going to explain what the parts are here.
Okay. The most tedious thing about this project is actually simulating our power grid. So how we start off is from the utility station, this part over here. You might see a tag over there that says grid station. Underneath that is a switch to an AC generator located in another room. It's connected with the resistor barrels, the capacitor, and the inductor loads. These represent our typical loads found in a system such as housing, factories, etc. This component over here represents our DG unit, and which is connected by a DC generator again, somewhere else. Our main focus is over here, the EVM and the voltage source converter. The EVM tells the VSC to provide power. It helps with injecting our special negative sequence signal. It helps detect an actual island. And I'll just leave it off to Rosan to explain our actual solution.
Thank you, Vonia. Right now I'm going to give a live demonstration of our circuit. So as Vonia mentioned that this is our normal condition, and we're going to simulate that situation first. And after we do this, we're going to create an island where Matthias is going to flip off the AC panel switch, which represents the station breaker, which is going to pop off when a fault or whenever disturbance occurs in the line. So, and upon that, once that happens, how are we going to detect this situation? Well, first, we're injecting negative sequence signal into the grid continuously, and we're monitoring it at the same time. And what's going to happen is that right when an islanding occurs, the negative sequence signal is going to shoot up, and we're going to use that to detect islanding. So right now we're going to turn on our systems to simulate the scenario 1, the normal case. Matthias? So right now nothing's happening, but right now we are supplying power as well as injecting negative sequence signal. And if you look here, this curve represents the negative sequence signal that we're measuring right now with the injection included. And that's the signal that's going to increase when we trip off the generator. But before that, let me show you that our generator is providing 400 watts power. This is connected to our generator, so this is per phase, 400 watts. And if you look here, this is the ammeter, which is reading 0 amps right now. So that means all the power that is being provided by our generator, our load is basically consuming all the power that is being generated by our generator, and it's not coming from the utility grid. So now Matthias is going to create an island by turning off the AC switch, and notice the negative sequence signal here. So 1, 2, 3. So as you can see, the voltage increased, and our user interface has also detected that an island has occurred. And once this happens, we disconnect our generator to mitigate all those problems that was mentioned earlier.
All right.
Thanks, guys.
Any question?
I actually have a question. It's a very neat solution.